Okay, for our last section, for our last type of graph, we're going to look at something called lemniscates. And these are, well, I think the best thing to do is probably just to go ahead and take a look at them. I don't need that one anymore. I have two versions here because I'm going to go from 0 to pi and see what happens there. And then I'm going to go from pi to 2 pi and see what happens there. Now, I'm taking the square root. Normally, these are written as r squared equals sine squared of 2 theta, or 3 sine squared of 2 theta, for example. I'm just going to stick with a coefficient of 1 for now. But I can't do that in Desmos. So I'm only going to get the positive version of the square root here. So when sine is 0, when theta is 0, sine is also 0. So I'm going to be starting at the origin and moving into the first quadrant and coming back to the origin. And that looks like that's all I'm going to get. Let's see what happens. This should only go to pi. See what happens if I continue. Nothing. And the reason for that is that although I'm still in quadrant 2 between pi over 2 and pi, when I take values between pi over 2 and pi and double them, that's what's happening there, that pushes the angle I'm taking the sine of into quadrants 3 and 4. That means that the sine of that angle, that value, will be negative, and I can't take the square root of a negative number. So I'm not getting anything, nothing's happening between pi over 2 and pi. I'm not getting any additional graph. Okay, but what happens when I pick back up at pi and go to 2 pi? Well, at pi, when I double that, I'm starting at 2 pi, right? So it's kind of like I'm starting at 0 again. But this time, I'm going to go into quadrant 3. And again, when I get to the equivalent of pi over 2, which is 3 pi over 2, when I keep going, nothing happens. Because in between 3 pi over 2 and 2 pi, when I double that angle and take its sine, I'm going to get a negative answer, and I can't take the square root of a negative number. This shape is called a lemniscate. Funny word. I really don't know what it means. I'm going to turn these back to 0 and change this to a cosine because I want to look at what happens there. Now, a cosine graph tends to hug the x-axis, and a sine graph, if it's going to hug any axis, will hug the y-axis. But it's a rotation of cosine, so it may not hug any axis. In fact, the one we just looked at didn't hug any axis. What it did hug was the origin. Remember that sine is an odd function? That means it's symmetrical about the line y equals x. That's kind of an interesting coincidence, if it's a coincidence. All right, let's take a look at the cosine, the square root of the cosine of 2 theta. Starting at 1, 0. And instead of starting at 0 and making a loop and then carrying on and making another loop, I started at 1 and made half a loop. Continuing on, nothing. Nothing at all for a while, because I'm going from 0 to pi over 2, and then from pi over 2 to pi, and through pi over 2 to pi, cosine is negative. And then from pi to 3 pi over 2, cosine is also negative. And it's not positive again until I get into quadrant 4. Well, if the cosine value is negative, I can't take its square root. So until I get to 3 pi over 2, I'm not going to see any more action. Finally, I can see the rest of that part of the graph. So now what might have been happening here is a second loop here. Let's see. That's the first half loop. I might have had a second loop here and then a third loop here. I don't know. And then finally the second half loop here. But I'm not getting I'm not getting any values between pi over 2, sorry, pi over 2, and 3 pi over 2. It's not until I get to 3 pi over 2 that I get the rest of my graph. Okay, now starting at pi, let's see what happens. Now, remember that I'm plugging pi in here, so I'm actually graphing from 2 pi, right? So starting my point is going to be pi comma something, but the value that I'm plugging in pi gives me cosine of 2 pi. And that is a legitimate. That's like saying the cosine of 0. So I should get something right away. And then I get to pi over 2. And then I get nothing. And then I get nothing. And then finally, I get the rest of the graph. So the lemniscates are really quite an interesting class of graphs. You can use these to graph things like six-petaled roses. I guess I have to change both of these. That's an interesting shape too, actually. It's not what I was going for though. You can graph these to use these to graph various different kinds of things, but the lemniscate is kind of defined by the argument being 2 theta. So by and large, when we say a lemniscate, we mean that the argument is 2 theta. That's really all I wanted you to see about lemniscates. They're not terribly common, and I'm not sure how much we'll see them again, how much we'll run into them again in this course, but I did want you to see them because they are an interesting phenomenon. So this video at least was blissfully short, and that is going to do it for this topic.